This week we're going to be looking at the science of global warming, and part of our classroom discussion is going to be about what it means to save the planet. When we look at global warming, a lot of times we can feel overwhelmed by the large list of impacts, and we're going to talk about how we see our relationship with the environment, whether we are in control of nature or whether we are part of nature. So let's review a little bit about how heat interacts with Earth's atmosphere. Most of the heat in the atmosphere originates with the sun. The electromagnetic spectrum on page 14 lists all waves in order from shortest to longest wavelength. And you can see on the left side is all the shortest waves and the right side is all the longest waves. Sunlight that we get is mostly on the short wave side of the electromagnetic spectrum. Most sunlight comes in the form of visible light. So the basic way that the sun interacts with the atmosphere is that the shortwave radiation comes into the atmosphere, heats up the Earth, and then long wave infrared radiation in the form of heat heats up the air. Now, if this was the only thing that happened, the Earth's average temperature would be negative 18 degrees Celsius or 0 degrees Fahrenheit. Fortunately, we have something called the greenhouse effect. That's basically where shortwave radiation from the sun, it can enter through the glass of a greenhouse, and then it heats up inside the greenhouse, and then the heat in the form of long wave infrared radiation can't escape through the glass, and that's why a greenhouse gets hot. The same thing happens on Earth's atmosphere. CO2, which is carbon dioxide, CH4, which is methane, and H2O make up less than 0.1% of the atmosphere, but they're able to return 84% of the sun's heat from the Earth. Well, we know that CO2 is one of the main greenhouse gases, and the question is, where does it come from? Well, it turns out about 95% of the CO2 in our atmosphere actually comes from natural sources. About 5% comes from human-made emissions from fossil fuels or cement production and deforestation and changing land use. Now, even though this is only about 5%, that's enough to upset the balance in what's called the carbon cycle. The basics of the carbon cycle was where animals breathe out carbon dioxide gas and plants will breathe it in, and then the plants breathe out oxygen, which is what animals, including humans, need to survive. In this class, we'll learn that it's a little bit more complicated than that. When you breathe out carbon dioxide, for example, about 50% of it enters into the atmosphere. About 26% of it is absorbed by plants, and then about 24% of it is absorbed in the ocean. We can see here that when you have more carbon dioxide in the atmosphere, less heat is able to escape from the Earth. Earth's atmosphere has changed many times in the last 4.6 billion years. Early in Earth's history, the atmosphere used to be as high as 39% carbon dioxide. Today, CO2 makes up only about 0.039% of the Earth's atmosphere, but again, that's enough to make a really big difference in the temperature on Earth. The concern was first proposed by a guy named Svante Arrhenius. He said back in 1898 that if we doubled the amount of CO2 in the atmosphere, this could result in a temperature change of about 5 to 6 degrees Celsius. Well, what he saw back in 1898 was a graph that might have looked like this. About 100 years later, today, this is the graph that we see. You can see that the amount of carbon dioxide in the atmosphere is over 360 parts per million, which is very high. You can see that for 650,000 years, the atmospheric CO2 has never been above 300 parts per million. Today's CO2 levels are over 400 parts per million. What changed to put all of this carbon into the air? A lot of this started during the Industrial Revolution. We saw some really big changes in how society interacted with its environment using more machines and more factories and more travel. We are extracting fossil fuels from the earth, and all fossil fuels are based off of these hydrocarbon chains. And when you burn them, you are creating a reaction which creates carbon dioxide in the air. About 86% of our fuel needs come from fossil fuels. The other remaining percent comes from nuclear energy, hydroelectric energy, and a very small amount comes from alternative energy like wind and solar electricity. We can see here that we spend about 33% of our energy on transportation transportation, and about 66% of our energy on electricity and thermal energy or heat. And lastly, we can see this map below shows the proportions of people and how much energy they use. And you can see that an average American uses more energy than any average citizen of any other country. And so that's one of the other things we'll be discussing a lot in class this week.